chat. Let me record. All right. So looking at properties of linear functions. Let me write that better. So we're going to go to our intercepts. Start right here. You guys want to use 3.2. So your intercepts are going to be where the graph intercepts or crosses the x-axis and y-axis. So your x-intercept will be where the graph crosses the x-axis. Your y-intercept will be where the graph crosses the y-axis. So characteristic of all x-intercepts is that y is always 0. Characteristic of all y-intercepts is that x is always 0. All right, so I'll give you a chance to write that down.
Can you say that again?
All right, so your intercepts is where the graph crosses, well, your x-intercept is where the graph crosses or intercepts the x-axis. Y-intercept is where the graph crosses or intercepts the y-axis. So I have that right here. It's the same thing. Yep. And so for your x-intercept, y is always 0. And then for your x-intercept, I said it backwards. For your x-intercept, y is always 0. And then for your y-intercept, your x is always 0. And so all that's right here, though.
What does that say after intercepts underneath x-intercept?
Right here?
It says the, yeah, what's that?
Crosses. I need to write that better. It says crosses. Yeah. All right. See something really quick. Okay. And also, that's reflected in our coordinates. 0 for x for your y-intercept, 0 for y and your x-intercept. All right, can I scroll up? All right, so if you want the graph by using our intercepts, let me erase some of this so we can walk through it. We'll put it back. All right, so if we want to use our intercepts in order to graph, we have to find them first. So of course, the first thing, decide which one you're trying to find. It doesn't matter which one you decide to find first. I went with x-intercept, but remember the key to all x-intercepts, characteristic of all x-intercepts is that y is equal to 0. So I plug in 0 for y. 3 times 0 is 0, and that leaves us with 2x equal to 12. Divide by 2 to solve for x, and x is equal to 6. So that means the coordinates of my x-intercept is going to be 6, 0. Let's see this one in the chat. Yep, just shoot me that email. That's fine. Shoot me that email. With your work in it, that'll be fine. All right, so that's our x-intercept, y-intercept. You let x be equal to 0. And that's what we did here, 2 times 0. That'll be 0, leaving me with 3y equal to 12. Divide both sides by 3. And y is equal to 4. So our intercept here, y-intercept, be careful. Remember your ordered pair is always x, y. So it means you're going to have 0, 4 as your y-intercept. Make sure we're okay. Oh, not a problem. Not a problem at all. All right, so any questions on how we found x-intercept, how we found the y-intercept? Once again, uh, with the equation that they give you, they gave us 2x plus 3y equal to 12. To find the x-intercept, we let y be equal to 0, solve for x. To find the y-intercept, we let x be equal to 0, solve for y. Then,
I'm sorry.
say again?
I was asking a question. How did we what did we divide?
At this point right here in both of these cases, is that what you're talking about?
Yes.
Yep, in order to get 2 off of x, you got to divide both sides by 2. And then in order to get 3 off of y, we had to divide both sides by 3.
Okay.
All right, anybody else before we graph? So you put those 2 points on the on your Cartesian coordinate plane. Here we have 6, 0, and there we have 0, 4. And connect your line, connect your dots. That'll be your line. All right, any questions? All right, so let's take that and go back to that word problem we had. We're going to do the same type of thing. So here we have, after a parachute is deployed, a function that models the height a parachutist above the ground, models the height a parachutist above the ground, is above the ground, should have is there, is above the ground, is f of t is equal to negative 10t plus 2800, where f of t in feet of the parachutist, t seconds after the parachute is deployed, find the intercepts, and then explain what they mean in context. So, as you guys write, just re-explaining what we got going on here, or just explaining what we have going on here. We have someone that's going to jump out of a plane or some type of vehicle in the air, and they have a parachute. They're going to deploy that parachute. T is going to be the seconds after they have deployed the parachute. All right. And then feet, F of T is going to represent the feet above the ground. All right. So it tells us to find the intercepts. Now remember, in order to find the intercepts, we let x, or the value we're plugging in, to be equal to 0, solve for y, and then the other value, plug that in for 0 and solve for x. All right. So if we look at right here in this purple, that's the given. We have t, that's going to represent our seconds after the parachute is deployed, and then f of t is our feet. So remember, we talked about function notation. F of t is always going to be your y, and that's what I have right here, which is going to represent our feet. And then the value you plug in is the same thing as x. So f of t is the same thing as your y, and then the value you're plugging in is the same thing as x. So we're going to treat them the same way we did in that last problem, when we let one be equal to 0, solve for the other, and then flip the roles and solve for the one that's missing. All right. So the first one, we start off by letting t be equal to 0. And remember, t is our time, our seconds. So you're talking about 0 seconds, no time has passed. So you plug in 0 into the function.
Is that a 6? 6t?
All right, I don't know where you're talking right here or.
Yeah, right there.
No, it should be let. I wrote that a little lazily. Should be let.
Oh.
Yep. So that was on me. So we want to let t be equal to 0. All right. So you plug 0 into the function, and we have 2800. It represents 2,800 feet. In other words, at t equals 0 seconds, no time has passed. The value that this function gives us is 2,800 feet. So before we talk about what that means, everybody okay with what I did? All right, so in the purple, that's what it means. At t equals 0 seconds, the parachutist is 2,800 feet in the air. All right, next one, we're gonna let f of t be equal to 0. Let me erase this. All right. So we let the other piece be equal to 0, f of t be equal to 0. And remember, when you go back to our original function, notice f of t was right here. And so that's why I have 0 right there. We let f of t be equal to 0. In other words, that represents your feet. So when the feet is 0, what does that mean? So before we explored when t, our time, was 0, no time has passed. What does that mean? Now we're looking at what does it mean for feet to be 0. All right, so now we solve for t. Subtract both sides, or 2,800 from both sides. 2,800 will cancel on the right side. That leaves us with negative 2,800 equal to negative 10t. Then we'll divide both sides by negative 10. And that gives us t equal to 280 seconds. So what that means is that when the feed is 0, that's when it'll take, in other words, it'll take 280 seconds for the parachutist to hit ground or touch ground. All right, so 0 feet above the ground. All right, questions? Any questions on what we did there? All right. So let me see if there's anything else over here before we, okay. So any other questions before we go to slopes? All right, so let's look at slopes. This is still 10.2. First they did intercepts, then they did the slopes. So slopes, m equal to y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. So it doesn't matter which way you do this, just know that either way you'll get the same answer as long as you stay consistent. So in other words, if I do y2 first on top, make sure you do x2 first down bottom. Or if you do y1 first on top, do x1 first on the bottom. You keep that in mind, then you'll still get the right answer. In the first example, I'll do both ways so you'll see what I mean. But of course, when you do it on your own, you only have to do it one way because either way you'll get the same answer. Then we have here rise over run, in which we will use that to graph. So we'll talk about that as well. So that x1, y1, x2, y2 are just any 2 points on the line. And the slope is just going to be a representation of the steepness of that line, the incline, the slant. Gives us a numerical value to assign to that slope, to that steepness or that ramp, that slant. Also, you'll see when we get into graphing, it will be instructions on how to carry out that or draw that line. All right. Let me scroll up. We're good. So first one we want to look at is they give us 2 points and ask us to find the slope. So a line has to pass through these 2 points. We have these 2 points that are on the same line, and we want to find the slope. All right. So -2, -4 is the first point, so I call it point 1. Second point, 3, -5, point 2. So it's up to you. It doesn't matter which one you call point 1, which one you call point 2, as long as you plug them in correctly. But once you go to plug them in, you'll see how that'll work. But you always want to label them so you can stay organized. Which one you call them point 1, which one you call them point 2. All right, so first way to do it, y2 minus y1 over x2 minus x1. So make sure you're careful with your substitution. We have -5 for y2. Then for y1, we have -4. Make sure you don't lose a negative. There's a minus sign in the formula, and you're substituting in -4. Sometimes people lose a negative in their substitution, so be careful with that. And then for the second one, x2 is 3, x1 is -2. So don't forget negative to negative is positive. So that's -5 plus 4, 3 plus 2. That'll give us -1 over 5. All right, so looking at the next one. Same one, excuse me, but doing it the other way. Remember I told you if you do it y1 minus y2 over x1 minus x2, still get the same result. So this time we're plugging in -4 first, minus -5,
Can you
then
go up just a
-2.
tad bit, please?
Say again, go where?
Just up a little bit, just like a little bit.
Yes. That good or you need it?
I need to see like the first like black part. Right there.
So then we have plugging in those values, -4 minus -5. Then on bottom, -2 minus 3. And that'll be 1 over -5, which is still -1 over 5 as our answer. So make sure we're good before we go to the next one. We're just going to do slope one more time, find slope according, if they give you 2 points. Make sure we're good with that. All right, is everybody okay? Hold up. Let me go up too fast if anybody still need it. Cause I would magnify it a little more. Okay, so next one, give us the 2 points, 5, -6, and 8, 3. Once again, I label the first one 0.1 and the second one 0.2. And then plug in accordingly. My y2 is 3, y1 is -6, x2 is 8, x1 is 5. So 3 plus 6 on top, which is 9. 8 minus 5 on bottom, 3. So 9 divided by 3 is 3. And that will be our slope. All right, questions? Any questions? All right. So we have 4 basic behaviors of our slopes. If you follow your graph going from left to right and it's going up, from left to right, if it's going up, your slope is positive. From left to right, if your line is going down, your slope is negative. All right. If you have a horizontal line, your slope is 0. If you have a vertical line, your slope is undefined. All right. Scrolling up. Are they okay? Don't copy parallel lines. Just give everybody a chance to copy this other stuff. So good with behavior slopes. All right. Don't need that. Here we go.
I didn't get the third and fourth one.
See, you wait until I got all the way down here.
I know, but I couldn't see it still.
It's all good. I'll just mess with y'all because I can. It's all good. All right. Let me know when you finish and then we'll scroll down.
Mm-hmm. Okay.
All right. Thank you. Anybody else before we scroll? All right. All right. So let's look at graphing using our slopes. And we mentioned rise over run initially. And the rise is going to be our up or down option. Run means left or right. So what will dictate whether we go up, down, left, or right will be if we have positive or negative numbers in our numerator versus denominator. So our positive moves will be up and right, negative moves down and left. All right. So if I look at having a slope of 3 over 4, M represents our slope. So that's a positive 3 over positive 4. So it means I will go up 3, right 4. Positive 3 over positive 4. That's telling us to go up 3, right 4. Now, if I have negative 5 over 7, What I normally say is just give the negative to the top number to be safe. Because what you cannot do is write -5 over -7, because that will be positive. 5, 7. No, -2 negative is positive. So that negative can only be assigned to the top or bottom. So I always say to be safe, just give it to the top and you'll be all right. So that would be a -5 over a +7. So it means down 5, right 7. But if you decide to give the negative to the bottom number, that means we have a +5 over a -7. So that's up 5, left 7. Either way, you'll still get the same result. And so what I mean by that, let me erase some of this on this line. So if I have this point right here and I go down 5 and right 7, that'll put me right here. But if I go up 5 and left 7, that'll still put me right here, creating the same line. So either way, you'll be fine as long as you only give the negative to either the top or the bottom. You can't give it to both. So this slope, always remember that it's not a point, so you don't go to the origin. You always go to a point that's on the line and then generate another point by using these instructions. So you go to the point, go up 3, right 4, that'll give you another point on the line, and vice versa.
Are you able to go down a little bit so I can see like after or that part? Not that one. Yeah.
That's good?
No, move it up more so I can see like the mini graph and
So with that?
equal 5 over 7. Yeah.
All right, guys, let me know when you're finished.
Okay.
All right, thank you. Anybody else first scroll up? Good. All right. So let's look at a slope-intercept form. Whenever we take our linear equations and solve them for y, simplify the equation, then what's sitting in front of x is our slope, and then the other number is our y-intercept. So if we look at y equal to 2/3 x plus 1, what's sitting in front of x is our slope. So be careful with that. Some people make the mistake and write their slope as 2/3 x. The slope does not have a variable involved with it, so it's just 2/3. Your slope is just a number. And then the other number is 1, which is our y-intercept. All right. Same thing with this one down here. We have y equal to -8 over 13x minus 5. So the -8 over 13 will be your slope, and your y-intercept is -5. All right. Any questions? Any questions so far? All right. Scroll up. All right. So using the slope to graph, first thing you do is going to plot the y-intercept. Notice I said plot the y-intercept first. And then you're going to generate another point from the y-intercept with the slope. So your slope is a bunch of information given us, or directions, I should say. Your slope is some directions for us to be able to generate another point. But we have to plot the y-intercept first. So here we have, let me erase this. So here we have, got my eraser. Y equal to 2/3 x minus 1. Remember, whenever your equation is solved for y, that means we can just pick out our slope and our y-intercept. So we see our slope is 2/3 and our y-intercept is -1. So slope is 2/3 and then the y-intercept is this -1 here. Now that's a +2 over a +3, so that means we're going to go up 2, right 3. And don't forget, as a coordinate for your y-intercept, you know, x is always 0. So that's where we got this 0, -1 from. They gave us -1 from the equation, and then 0 is the x whenever it's a y-intercept. Any questions on the information that we've extracted from the problem? So we want to graph it once again. We want to graph, we want to go green. We want to graph this point first, 0, -1. So 0, -1 is right here. Then from the y-intercept, I'm going to go up to right 3. And that'll put me right here. That'll be my line. Make sure we're okay. All right, so let's do it at least one more time. So we have y equal to -1/4 x plus 3. Same type of deal. Our equation is solved for y. So what's in front of x is our slope. That's -1/4. The other number is 3. So that's a -1 over a +4. So that means we're going to go down 1, right 4. And then our y-intercept is 0, 3. So we graph the y-intercept first. All right, just had an infiltrator. So hold on one second. All right, sorry about that. So we have, you know, I see somebody talking about their connection. Well, at least, at least you'll have connection and interruptions at the same time. So we have -1 and 4. We're going down 1, right 4. And then we're going to graph this 0, 3. So I graph 0, 3 right here, the green dot. And then from that green dot, I'm going to go down 1 and then right 4, just right here. And that'll be the line. All right, questions on that? Let me see, I think that's it for 10-2. Slope, graphing using slope.
How did you get that again? I'm
Which part?
confused about the last one that we just worked on. I'm
Now, when you
confused
say
about
when you say how did you get that? Now, when you say that?
like -1 and 4, down 1.
So
Right.
you're not talking about this right here, though. How do we get this? 'Cause
Yeah, that one.
now that was just the problem. So they just gave us this. They will give you this. And so
Mhm.
what's in front of X is your slope. That's M. And so that's why I have that right here. And then the number not attached to X is your Y-intercept.
Okay.
And then from there, we are leaning on, if it's my slope, I'm leaning on, oh, where'd it go? Leaning on this right here.
And
So
how did you do negative?
you said, how did I do -1? You broke up. Say it again. Did I lose her? Did we lose her? Maybe type it in the chat.
Hello.
Hello? Yeah, I hear you now.
I was asking how did you do -1/4? Because I'm confused. It's like on the y-axis, and then you go -1 down. And
Okay.
then it goes.
Okay, so let me make sure you're clear on this. So you're okay with where we got this from, right?
Hmm?
Are you okay with where we got the instructions down 1, right 4?
Yeah.
Okay,
I know.
okay.
Okay. I don't know that.
So you're talking
I
about
don't know.
when we're plotting. Okay. So the first thing
Because
you're going to do, okay, go ahead.
I thought you start from 0 and then you go down 1.
Right, you do that when you have a point. And so your slope is not a point, it's information. So what
Okay.
you have to do, and this is why you always have to graph your y-intercept first. Now that's a point, and that's where we will start from the origin. So you go start from your origin, and you go up 3 because you couldn't go right or left, with X. All you had was 0. So now this is not a point, this is information. So what it does is it gives us the ability to generate another point from the y-intercept. So you start at your y-intercept and go down 1 and right 4. Oh, right 4.
Oh, I see how you did it now. Okay.
Yeah. So you
I
always
understand.
gotta, yep. So just to make sure everybody's with us, and I dropped my line there, missed it, but it's all good. So you always graph your y-intercept first, and then from the y-intercept, you go down 1 and right 4.
Okay. But that's not with points, right?
Not with points, right? You're absolutely correct. With points, you always start at your origin.
And the one we did at the top was points, but this was not.
No, the one we did the same thing. I'll go back up to it. Give me a second. Let me go ahead and write this
Okay.
line. So notes. So we did the same thing here. The first thing we did was we graphed it. We graphed the y-intercept, which is right here, 0, -1, and then from that y-intercept, we go 1, 2, then 1, 2, 3, and that puts me right here. All right. All right. So is that okay? Make sure we're good. Everybody, not just her, but anybody. Make sure we're good with that. So once again, we graph the y-intercept first. Then from the y-intercept, we use our slope information. Up 2, right 3. And then here it was down 1, right 4. All right. Anything else before we, I know I had some general questions that people had. Anything else about anything I've said today? Make sure we're good. All right.
Oh,
So,
I have questions about the homework 10.1.
okay. All right. So I had some people in the chat that had some set up first. So let me get them. Then I'll get
Yes.
yours.
Mhm.
So let me go to my other screen. Let's go to 3. All right, so basically I just need a whole another review sheet. You know, it's gonna be that deep. All right, so someone wanted to ask me a question after class. Yes, most definitely. Then Mr. Penner, he says, can you cover y equal to, now what were they asking you to do with that? Absolute value. Were they asking you to graph it, or did they give you some points?
Yeah, eventually you were come up with points and then graph it.
Okay. So they didn't give you any points though.
No.
Okay. All right, that's fine. So I'm just gonna do -1. Let's do 2. -2, -1, 0, 1, 2. All right, so this is the absolute value symbol.
Actually, I'm sorry. They did give you points. It was -5, -3, 0, 3, and 5.
All right, hold on, let me get those.
Sorry about that.
No, you're fine. All right, you said -5, -3, 0, 3, and 5.
Yeah, that's correct.
All right, cool. All right, so absolute value of anything. Let's say if I have the absolute value of -3, the result will be +3. If I have the absolute value of +3, the result will always be +3. So whenever
Is
you
that
apply,
is that what I'm sorry, that's what those brackets mean?
exactly. Uh-huh.
Okay, I never saw that before.
Yep, not a problem, not a problem. So yep, those lines, those extended lines, in that fashion. And just in case anybody wanted to know, when he said bracket, those are your brackets, but these are absolute values. So those are the difference between the notation. These brackets are just grouping symbols. They carry no value or no application. They carry no application. But when you see these, that means that whatever's on the inside, once you apply it, you have to give the positive result. So if I have the absolute value of 7/4, absolute value of 7/4 is going to be 7/4. Absolute value of -0.53 is going to be 0.53. So the absolute value always yields the positive result. So what's going to happen here is that we're going to plug in these values, simplify, and then the result is going to be still positive. So we got -5 for x. That'll be a -4. Absolute value of -4 will be +4. Plug in -3. -3 plus 1 is -2. Absolute value of -2 will be +2. Plugging in 0. Absolute value of 1 will be 1. Plugging in was +3. Absolute value of 4 is 4. And then last one, absolute value of 5 plus 1 is going to be 6. And so make sure we're good with anybody who's copying notes off of this. Let me know if you have any questions so far. Once, like he said, they gave these values, -5, -3, 0, 3, 5. You may not get those exact values when you do your problem, but this is still the same process. Plugging those values for x, simplify inside of the absolute value. Once you apply the absolute value, the result will be the positive number. So that's 4 and 6. So now when you graph, all right, so the first one was -5, 4. So I would go to the left 5, up 4, then go to the left 3, up 2, 0, 1. My tick mark's a little off, but it's all good. Then right 3, you're talking about 3, 4. Right 3, up 4. And then to the right 5, up 6. So you should get like a V shape. Yep. So absolute value will always give you some type of V shape. Yeah, not a problem, sir. Not a problem at all. All right. So that was Mr. Penner. I saw somebody, I think it was Jordan. Now, Jordan Jones, do you want to ask me after class or do you want to do that now?
I'll ask after class.
Okay. All right. So I forgot who I was talking to that actually had a question out of 10.1. Is she still here?
It was
Okay.
me.
Mm-hmm.
So the question is kind of like the one that you guys were working on, but it was y equal 3x minus 1.
Okay.
And it didn't give me any x and y.
Okay. And it just said graph?
Yeah, it just says graph.
Okay. So
And
you
when
can just,
yeah, go ahead.
no, you go ahead. What were you about to say?
When I tried doing like making my own graph and everything, it still didn't work. I did
Okay.
-1, -2, and then 0, 1, and 2, and it still didn't work.
Okay. So are there 2 points in particular that you use? Give me 2 points that you used.
I used, what do you mean? I just,
Oh, well, because you can use anything. So I didn't know if there were 2 points that you used already that didn't work. So I was going to try those 2 points and then let's see if we get the same numbers and everything like that. But it doesn't matter. You can just use 0 and 1.
yeah, 0.
Now, in WebAssign, you only can graph 2 points. So, just choosing 2 is fine. And you will plug them in for X. So it'll be 3 times 0 minus 1. 3 times 0 is 0 minus 1. And that'll be -1. So when X is 0, Y is -1. And then plugging in 1. Hold on a second. All right, 3 times 1 is 3 minus 1 is 2.
Let me see if it works.
Okay.
0. We put it in. I have it in right. Like I have it up right now.
Okay, cool.
It didn't work at all. I don't know why. Let me see. And then you said the second one was
1, 2.
1.
So 0, -1 is down here. Then to the right, 1 up 2 right here.
Okay. Oh, it worked.
All
Oh,
right.
that's crazy.
All right. As long as it
No,
worked.
it did not work.
It did not work?
It didn't work.
All
It
right,
didn't work.
something wrong with your computer.
Another place.
All right. So now let me ask you. All right. So now this is the right equation, y equal to 3x minus 1.
Yes. Y equal
And
3x minus.
they didn't give you any points. Now, are you using when you
They
click?
didn't.
Go ahead. I'm sorry.
They didn't give me any.
So now when you click on this right here, you're not switching it to this or this, right?
I'm switching it to the dots. I'm putting in the dots.
Okay. Now, is it asking you for a line or is it asking you for the dots? Let me see if I can pull it.
It just says graph the equation. It doesn't
Okay. So
anything.
now,
Because that's what I was trying to figure out.
Yeah. Are you
Weird.
clicking on this right here first? It should be a line with 2 arrows. It's a box that has a line with 2 arrows on each end.
No, I'm not on that.
Okay.
Should I have clicked on it first?
Yeah, click on that and then hit your 2 points and it'll make the line for you.
Okay.
So where's my, it'd be cool if it's not in.
It'll work
Okay.
this time. Oh, it worked.
Word at a time? Okay. Cool.
Yeah, I just didn't have the line through it, but I have the
Gotcha.
dots.
Got you. So let me show everybody else since we're here. So what I was talking about is this point. If you haven't gotten here, you want to click on this and then click your 2 dots. It's not letting me graph. Click on this. get my thing. All right, so now my line. For some reason, my point is not working. But anyway, you would click on this button right here. And for some reason, my touch screen is not working right now. Anyway, and then you would just put your points. Why is this not? Anyway, at least you know how to do it. I don't understand. Why is this not clicking right now? And I just did it for the last class. But you click on this right here, guys, and then you'll be able to click your 2 points. Gotta have the points first. Yeah, no, but I still can, now this has nothing to do with that. I have, even if I wanted to choose some random points, I still should be able to do it. For some reason, my touch screen is not working right now. Give me 1 second, let me try this. Trying to show you guys this thing. Let's try doing it this way. One more thing. That's weird. It was just doing it last class. Okay, maybe it was my pen that needed batteries. Well, see, Desmos is good. Yeah, Desmos will work for you, but if you have to put it in WebAssign, it's not going to do it. For some reason, like I said, it was working okay earlier. I'm understanding why it's not working now. Well, Ms. Campbell, it worked for you, right?
Yeah, it works.
Okay.
All of them, like the answers that I had 3 of them wrong, but I just need to put it in the line. I had all my stuff right. I just need to put in the line. That's all.
Okay, that's good. And I might have to log out and log back in. Maybe it's acting funny because it's been sitting up ever since I left my last class. But yeah, but that's how you guys would do it. But outside of that, any other questions? Any other questions? Make sure you're good. All right. So with that being said, we can go ahead and close out. I see somebody in chat. All right, cool. So we'll go ahead and close out today. Next class, we'll get into 10-3 and go into the weekend. All right. All right, not a problem. Thank you. And I'll see you guys on next class. Y'all have a good one. All right. Yep, you do the same. Thank you.
Oh, hello.
Oh, yeah, Jones. That's right. You had a question. I'm glad I didn't hit the end quick. What you got? Hold on.
No, it's all good.
Let me stop the
Okay.
recording.